Hey there, geometry. We are starting a new unit today. We are in Unit 4. We're going to talk about right triangles. Right triangles are pretty important. It's one of the concepts that actually you can use throughout your life. I know talking to my own dad, who builds a lot in his garage and works a lot with his hands. He uses the concepts of right triangles to make sure that things are square, to make sure that everything is, equal side, that angles are 90 degrees without measuring angles, etc. So, let's just jump on in. So first of all, let's look at our warm-up. Triangle ABC is similar to triangle DEF. Let's write as many equations as we can to describe the relationships between the sides and the angles of the two triangles. So this has a lot to do with the last unit that we did. Let's start with angles. We can say that, I think my pen is on, yep. That's really thick. Hold on. There we go. So we can say angle A is congruent to angle D. We can say angle B is congruent to angle E. And I didn't even look at the drawing. I looked at how it's written. Okay, and then angle C is congruent to angle F because similar triangles have congruent angles. Now let's talk about the sides. We can say that a ratio AB over DE is equal to the ratio of, BC over EF is equal to the ratio, let's just say CA over FD. So all those ratios are equal. We can continue on. We can say DE over AB is equal to EF over BC is equal to FD over CA. I can also say that CB over CA is equal to FE over FD. Let's talk about that one real quick. I said CB over CA is equal to FE over FD. All right, that's new, but really important to today's lesson. If I do the ratio of the hypotenuse over what looks to be the short leg, so hypotenuse, short leg, over hypotenuse, short leg, they will be equal. Oh, short leg. All right. Okay, can we calculate? So find the values of x, y, and z. If there's not enough information, what else do you need to know? So with this first triangle, I think there is enough information. We can use the Pythagorean Theorem. We can say 3 squared plus 5 squared equals x squared. 9 plus 25. 9 plus 25 is 34. Take the square root of both sides, so x equals square root of 34. I'm not going to calculate that. We can just leave it like it is. I can do the same thing with triangle 2. I'm only missing one side. This is the hypotenuse. So I can say y squared plus 4 squared equals 6 squared, right? Y squared equals 16 plus 36. Nope. Got ahead of myself in a very strange way. Sorry. Plus equals, I'm going to subtract 16 from both sides and then take the square root of both sides. So y equals the square root of 20, which we're just going to leave it like that. It's no big deal. Now this next one, I actually don't have enough information yet because I have two unknown sides. Okay, I'm not sure what JG is. We can name that, side A, If I use Pythagorean Theorem, I'm going to say that a squared plus 3 squared equals z squared. I have two unknowns. I don't know how to solve that with the information I have right now. All right? So what we're learning today is how to solve this type of triangle. All right, hold on a second. All right, so yeah, I don't have enough information for rectangle 3. And so the purpose here is to discuss whether it's possible to calculate z. We can do it, and we're going to use this angle to help us. All right, what else do I want to tell you about this? All right, so we're going to move on to the next little task. Okay, before we get to this, I need to take care of one thing, so I'll be right back. All right, I'm back. I know you didn't notice I was gone, but I always seem a little discombobulated when I leave for a second. The next task statement, is it accessible? Some buildings offer ramps in addition to stairs, so people in wheelchairs have access to the building. What characteristics make a ramp safe? So what would we talk about if we wanted to make a ramp safe? I mean, if you think about it, probably this angle would make a ramp safe, depending on how long this is and how tall this is. That ratio, if this is really, really long, this can be higher because that angle would still be sort of short. If this was really, really long, then this could be taller, which would make that angle sort of short. So this angle is pretty important, and you can compare that angle by talking about the height, the length of the short side, the short leg, and the long leg. Compare that ratio of those two has a lot to do with this angle right here. So that would be characteristics that would make it safe would be a small angle of elevation, it's called. Yeah, a small angle of elevation depending on how long your long leg is and how high your short leg is. So a school has 4 steps to the front door. Each step is 7 inches tall. So what, 1, 2, 3, 4. Each step is 7 inches tall. Design a ramp for the school. So that total height would be, what, 28 inches? Never likes it when I draw off the paper. This is where we would have a little bit of fun in the classroom. So if that's 28 inches, how long do you think the long leg should be? I don't know, definitely more than 28 inches. If you think about, I don't have a full-size ruler here. I have a piece of paper though. This is 11 inches. So the height here is 11 inches. We'd have 2 of those and be 22 inches. So, I mean, we're just here. If we had another piece of paper, 22 inches. So we'd probably want it to be more than 22 inches long. How long would we want that to be? Maybe twice that? So what, 28 times 2 is 56? Yeah. So maybe 56? Maybe another 28, maybe 84. So we want that long leg to be significantly longer so that the angle of elevation isn't too great. Your teacher will give you the Americans with Disabilities Act guidelines. Does your design follow the rules of this law? Okay, hold on. Let me grab it for us. It's right here in this pile of papers. All right, the America's Disabilities Act ramp guidelines states that ramps are required for any change in level greater than 1/2 inch. So anything greater than 1/2 inch needs a ramp. Ramps have a maximum slope of 1 to 12 or 4.8 degrees, And then ramps have a minimum width. I didn't even think about the width because the chair has to fit on it. It can't be a really skinny ramp. A minimum width of 36 inches. Ooh, 36 inches. There must be a minimum 5 feet by 5 feet flat area. So at the bottom it has to be 5 feet by 5 feet before the ramp starts. I'm not going to be able to draw before the ramp starts. And the slope of 1 to 12, let's see if I can get another piece of paper in here. Hold on, insert. No. So let's just do this. Let's insert some space. Oh, that's not good. That's okay though. I cut my picture in half. Insert some space. Alright, so let me draw again. We can talk about this right here. The slope would be 1 to 12. So if this was 28 inches, this would have to be 28 times 12. I was way off. It's sort of fun, isn't it? Which would be 12 times 28, 336 inches. I'm going to divide that by 12 to change it into feet. So that would be 28 feet. And then if I do 28 divided by 12, that is 2 1/3 feet. So if we're 2 1/3 feet tall, we need our ramp to be 28 feet long. And that ratio gives us a 4.8 degree angle of elevation. Okay, so a 4.8 degree angle of elevation is a ratio of 1 to 12. This is important. This is what we're sort of going towards for these lessons. 4.8 degrees gives us a ratio of 1 to 12, and that is our short leg over our long leg. All right? Let me do one thing. Yep, that works. Okay, just wanted to check one thing out real quick, but we'll talk about it next lesson. All right, that's really just the basic entry level for this unit, so we will continue on in the next unit. Good job.